There's a question then from the A2 paper. So this is a CCEA A2 Pure Maths papers from June 2023, and we're looking here at question 7, which is mostly trigonometry. So first part is using the compound angle formula for cos A plus B, prove that cos 2A equals 1 minus 2 sine squared A. So we simply need to expand out our cos A plus B, and we're going to change it then to A plus A. So that's going to give us then cos A minus sine A. So that tidies up then to give us cos squared A minus sine squared A. We know, of course, that we're trying to make it into 1 minus 2 sine squared, so we want to get rid of our cos squared here, and we know that cos squared is equal to 1 minus sine squared. So I'm going to exchange this in for 1 minus sine squared. 1 minus sine squared A minus sine squared A, and of course that gives us 1 minus 2 sine squared A as required. Find the exact value of tan 2A, where A is the acute angle sine to the minus 1 to root 7. So I'm going to set this up just as a wee right angle triangle first of all, and we can find then our tan of this angle, which is what we need. So it's the angle A, and we know that the sine of it is then 2 over 7, so that's the opposite, and that's the hypotenuse, so that's going to be a 2, and that's going to be root 7. To find this side here, let's just call it B, I suppose, to get ourselves going. We're just going to use some Pythagoras. So B squared plus 2 squared equals root 7 squared. That of course gives me B squared plus 4. Root 7 squared, of course, just 7. That means that B squared is 3, and this side then must be root 3. So how does that help us? It means we can find then the tan of that angle. So we know the sine of A is of course 2 over root 7, and then the tan of A is going to be the opposite over the adjacent, so it's then going to be 2 over root 3. So we're trying to find the exact value of tan 2A, so we're going to need our tan double angle formula. So tan double angle formula, tan 2A equals 2 tan A all over 1 minus tan squared A, and then fill in our blanks. So it's going to be 2, and our tan A is 2 over root 3, and that's all over 1 minus 2 over root 3 all squared. Starting to tidy it up, so the top line will tidy to 4 over root 3, and the bottom line then 1 minus, so we're squaring this, so top and bottom then squared. 2 squared gives me 4, root 3 squared then gives me 3. That's then going to be 4 over root 3 all over 1 minus 4 over 3. So that's minus a third. There's a couple of ways to solve from here. Of course, you can stick it in the calculator and hopefully it'll give you a third answer rather than a decimal. This is two fractions divided by each other, so I'm going to turn the second one upside down and multiply. So 4 over root 3 multiplied by minus 3 over 1. That gives me 12 over root 3. And I suppose then if I rationalise the denominator, I'm going to times top and bottom by root 3. It's a slightly slow way to go here, but that's okay. And we have a negative in there as well because of the negative here. And then that tidies in to give me 4 root 3. Probably slightly quicker ways of getting from there to there, but that gets us our answer anyway. Part C, the expression 2 cos 2x plus 5 sine 2x can be written in the form r cos 2x minus alpha, where alpha is between 0 and 90. Find the values of r and alpha. So we want to expand out this. So r cos 2x minus alpha, using our compound angle formula, is going to be r cos 2x cos, sorry, plus sine 2x sine alpha. We can go a couple of different ways in from here. I guess we can use a bit of Pythagoras and rewrite this. Or we could kind of do a thing here with sine, cos and tan. I'm going to go for this method. So with 2 cos 2x plus 5 sine 2x, and we rewrite this then as, so this squared gives me 4, this squared gives me 25, 4 plus 25 is 9, so it's going to be 29, sorry, root 29, 2 over root 29 cos 2x plus 5 over root 29 sine 2x. And I guess we want to compare then this with this. There are other ways, people do this different ways, so stick with me here. My r, I know, is root 29, that's what they've asked us then to find. And if we compare this, we can see then, there's my cos 2x, that's my cos 2x there, so my cos alpha is 2 over root 29, so cos alpha is 2 over root 29. And if I stick that into my calculator, so shift cos 2 over root 29, I should then get 68.2. You can see what I've tried to write there. Goodness me, I'm losing my mind here, putting the decimal place in. 68.2 degrees, that's my answer then to 3 significant figures. Final part then is using this then to solve the next bit. So hence find the solution of this between 0 and 180. This is a prickly enough one here because of the 2x and the 0 to 180, but we'll sort that in a wee second. So we're going to rewrite this bit because we kind of from the first part, so we can rewrite this then as obviously root 29 cos 2x minus, and we had 68.2, but the actual answer that came out of my calculator is 68.1986, just to give a wee bit more accuracy, and that gives 3. So you see what I've done there, I've exchanged that bit that I've circled for this here. That means then my cos 2x minus 68.986 is 3 over root 29. I normally let this equal a different angle, so cos theta is 3 over root 29, and then theta in this particular case then is 56.145. Some people at this stage change what the range is, depends what way your teacher does it, and so we can kind of rewrite the range here. I'm just going to fire on through here and see what we end up with. But the two things we need to deal with then, so if 2x minus 1986, and we're going to set that equal to, if you do your cast diagram here, hopefully you can just quietly see this. There's my 56, so it's obviously CAST. So I want this one here, and I want this one here. You can go with this and this, it just ends up being messier. It's actually easier if you take the minus 56.145. So if you do 56.145 here, you add 68.1986 to both sides, and you divide by 2, and you get x equals 62.2 degrees. And then for the other one, 2x minus 68.1986, and that gives you minus 56.145. So you see where I'm taking that from. I'm taking it from this angle here. You could go around this way and take us like 303 or something in and around there, or 300, yeah, and we can kind of do it that way. It just ends up being messy. This gives us a tidier answer. So we add 68 to both sides, and divide in by 2, and my other angle then is 6.03. Both of those then are given to 3 significant figures.